Okay, so let's look at this first problem. If we're going to use synthetic division to divide by x minus 6, remember it's x minus the number in the box. So if I'm dividing by x minus 6, then a 6 goes in the box. And then I'm going to have my coefficients and make sure every power of x is represented. Lots of 14s in that. Okay. Just make sure I wrote down everything correctly. Okay, so I'm going to get that started. So 1 times the number in the box gives me 6, and then we add. And 2 times 6 is 12, and then we add. And negative 2 times 6 is negative 12, and we add. And 2 times 6 is 12, and we add. And negative 2 times 6 is negative 12, and then we add. Okay, now, what I have here is the remainder. Now, if the remainder is not 0, which this is not, then 6 is not a 0. And if it's not a 0, then x minus 6 is not a factor. Okay. And so there was another question on that that's always on the final that a lot of you got wrong. But let's go ahead with this one. This is the remainder. These are the coefficients of my quotient. And so I'm going to start here. That's my constant. Then I have my coefficient for x, x squared, x cubed, and x to the 4th. So my quotient is x to the 4th plus 2x cubed minus 2x squared plus 2x minus 2, and my remainder is 2. Okay. And so that looks like it's be the last one there. Okay. All right, once again, we're going to use synthetic division to find the quotient and the remainder. Now, remember, it has to be the form, the divisor has to be the form where you can write x minus the number in the box. So x plus 2 has to be rewritten as x minus negative 2, and negative 2 is going to be the number that goes in the box. And then my coefficients for my dividend, I have 1 times x squared, 7x, and 3. Okay, 1 times negative 2 is negative 2, then we add. 5 times negative 2 is negative 10, and we add. So this is my remainder. Therefore, negative 2 is not a 0, because it's only a 0 if the remainder is 0. So x minus negative 2 is not a factor. i.e. x plus 2 is not a factor. But this question just wants to know the quotient and the remainder. Okay, so where this line is, these are going to be the coefficients of my quotient. That's going to be my constant, and that's going to be my coefficient for x. So my quotient is going to be x plus 5, and my remainder is going to be negative 7. And so that is matching up with the first selection there. Okay. All right, now this is very important. Number 3. The majority of you missed number 3. It's always asked on the final. The same type of questions, it's going to be different numbers. Look at this for a minute. Okay. Can we factor this? Well, yes, we can. 2 numbers that multiply together to give me negative 15, but add up to be positive 2. So that's going to be positive 5 and negative 3. So you can factor this. And we can see that that negative 5 is a 0 and 3 is a 0. That means if 3 is a 0, x minus 3 is a factor. And if I was to do synthetic division where 3 is in the box with this, my remainder is going to be 0. So if the remainder is 0, then the number in the box is a 0, and x minus the number in the box is a factor. If the remainder is not 0, as we've seen on the previous two examples, the number in the box is not a 0, and x minus the number in the box is not a factor. So this says the polynomial p of x is divided by x minus 3. So when I do synthetic division, it's x minus the number in the box. So the 3 is going to go in the box. And then it tells me that the remainder is negative 1. That means 3 is not a 0. The only way 3 is a 0 is if the remainder is 0. So this tells me 3 is not a 0. And 3 is not a 0 means the same thing as x minus 3 is not a factor. You must know and understand number 3. You will have one exactly like that, except with different numbers on the final. Okay, so x minus 3 is not a factor, and 3 is not a 0. That's the one we want. Okay. Also, you're going to have to know number 4 because that one in that form turns up on the final. So they want us to divide the polynomial p of x by x minus 3. So it's x minus the number in the box. And here I'm going to have the coefficients of my polynomial. 1 times x cubed, 4x squared, 4x and 5. Okay. So I do this. And I'm going to get 80. Okay, now, when it's done like this, this is my remainder. And these are the coefficients of my quotient. So starting here, my constant is going to be 25, my coefficient for x is going to be 7, and my coefficient for x squared is going to be that. That means I can write p of x is equal to the divisor, which is x minus the number in the box, or the thing you divided by, times the quotient, plus 80. Now, when you look at the selections, none of them look like this. So there is a second way you can write p of x. They don't want us to write p of x. They want us to write p of x divided by x minus 3. So if I'm going to do that, every term has to be divided by x minus 3. Every term. And so p of x divided by x minus 3 is going to be equal to, well, these are going to cancel. And I don't have anything canceling there. And so we can see that is going to match up with this one. Okay. All right, now what is the end behavior? This is not one that you can answer in your calculator. The end behavior is determined by the leading term. And in this case, the leading term is 3.005 times x to the 2, 3, 5, 5, 7, 1. So what we have, my leading term is a positive number times x to an odd power. And there was a chart, and there's 4 different things that the leading term could be. And when your leading term is a positive number times x to an odd power, the end behavior is going to be down up. We want that one. Okay, this is the rational zeros theorem. So remember, the rational zeros theorem are possible rational zeros. So I have f of x is negative 4x to the 4th plus 3x squared minus 2x plus 6. Okay, so the possible rational zeros are going to be plus or minus every fraction we can form of the form plus or minus p over q, where p is a factor of 6 and q is a factor of negative 4. So I can put a plus or minus out the front and we'll get that. So in the numerator, I could have plus or minus 6 and 1 and 2 and 3. And in the denominator, I have the, because I got plus or minus out the front, I have all the factors of 4, which is 1, 2, and 4. Okay, so here's my list. So plus or minus goes out the front. What if my denominator is 1? Then I'm going to get 1 over 1, 2 over 1, 3 over 1, and 6 over 1, which will all give me that. Okay, now what if my denominator is 2? Then I'm going to get 1/2, 2 halves, which reduces to 1, which is already in my list, 3 halves, and 6 halves, which reduces to 3, but it's already in my list. And finally, what happens if my denominator is 4? Then I'm going to get 1/4. 2/4, which reduces to a half, which is already in my list. 3/4, which is not in my list. And 6/4, which reduces to 3 halves, which is already in my list. That's my list. Okay. Now, okay, the only one that it can be, look at the whole numbers. You have the plus or minus out the front. We have 1, 2, 3, and 6. Okay, so the first 2 selections are good. The last 2 are not because they have a 4 in there. Okay, and here we have 1/4, 1/2. They have the 3 halves and the 3/4. Okay, what about this one? We have 1/4, 1/2. The 2/3 does not belong. Okay, 2/3 does not belong, so it's going to be this one. Okay. All right. Here they want you to determine where the graph crosses or touches. Okay, so if the multiplicity is even, then the graph touches and bounces back. If we have odd multiplicity, then the graph crosses through. Okay, so f of x is equal to 1/3 times x to the 4th, and they want you to list the zeros, okay, and x squared minus 5, and x plus 8. Okay, now here's another result that we should know by now. If you have x squared minus a number, it always factors, always. X minus the square root of k times x plus the square root of k. Now, if k is nice, like 9 or 25, then you don't have square roots. But if it's not nice, like 5 or 7, you get square roots. But using this rule, this is going to factor. Okay, so what are the zeros? Well, I can see 0 is a 0. Because if x equals 0, then everything goes to 0 because this is all a product. And what is its multiplicity? its multiplicity is 4. It's repeated 4 times. It has even multiplicity, and so it will touch and bounce back at 0. Now, the next 0 is the square root of 5, because that makes this 0, if x is equal to that. It has multiplicity 1. And so if its multiplicity is 1, that's odd, and it will cross through at the square root of 5. So it will cross through. Negative square root of 5, it will make that equal to 0. So it's a 0. And its multiplicity is 1, odd multiplicity, so it will cross through at the square root of 5. And then finally, if x is negative 8, that will make this 0. And so it'll make the whole thing 0. So negative 8 is a 0. It has multiplicity 1. So it has odd multiplicity, and so it crosses through at negative 8. Okay, so we're looking 0, multiplicity 4, and touches. So that first one's out. 0, multiplicity 4, touches. That's good. Negative 8, multiplicity 1, crosses. Square root of 5, multiplicity 1 crosses, and negative square root of 5, multiplicity 1 crosses. Okay, I don't need to look anywhere else. It's going to be that one. Okay. Now we're going to use Descartes' rule of signs to see the number of possible positive zeros. Okay. So let me get this up on the screen. So we've got now I need to count the number of times the sign changes. So I have a positive here, and it changes to a negative. That's one change. Okay, from here to here, there's no change. But from here to here, I go from negative to positive, and so that's a second change. So there are 2 changes of sign for f of x. So there will be 2 or 2 minus 2, which is 0. So 2 or 0 positive real zeros for the function. Okay. And so I'm going to find 2 or none. Okay. Now let's have a look at number 9. They want to know the number of possible negative real zeros for that. Okay, so if I'm going to get the number of negative real zeros, I have to count the number of sign changes for f of negative x. So I'm going to have to write that. Okay, so let me just make sure I can get it in there. Okay, so the first thing I have to do is get the formula for f of negative x. Now, we do not just go through here and change every sign. It does not work like that. If the power is odd, you change the sign. If the power is even, you do not change it. So the power is odd here, so I'm going to change the sign. The power is odd, so I change the sign. The power here is 4, which is even, so nothing changes. The power here is odd, so I change the sign. The power here is even, so nothing changes. The power here is odd because it's 5 times x to the first power, so I change the sign. And the constant remains the same. The constant is constant. Now, to see how many possible negative real zeros there are, I'm going to count up the number of sign changes in this. So I go from negative to positive, that's one change. Positive to negative, that's a second change. No change, no change, no change, and then negative to positive. 3 changes of sign. So there will be 3 or 3 minus 2. You keep subtracting 2. So there will be 3 or there'll be 1 negative real zeros. Now that matches this one. Okay. Now, find the intercepts. So x-intercepts are zeros. That's why when you're asked to find the zeros, and if you can look at it in a graphing calculator and see where the x-intercepts are, that gives you real zeros. Okay, so x-intercepts are found at real zeros. So what are my zeros? We can see here what value of x will make everything 0 if x is -1, if x is 4, and if x is 1. So those are real zeros, and so I get x-intercepts at these zeros. As points, they're written like that. Okay. Now, what about a y-intercept? There's at most one y-intercept. Y-intercept is found at f evaluated at 0. So I'm going to come back here, and everywhere there's an x, I'm going to replace it with 0. And if x is 0 there, I'm going to get -1 all squared. -1 all squared is +1. So I have 1 times -4 times 1. So my y-intercept is going to be the point 0, -4. Okay, now they've just given the values. So we have x-intercepts at -1, 1, and -4. But we have a y-intercept at -4, so that one's not right. We have x-intercepts at, this one says -1, 1, and 4. That's not correct. We have x-intercepts at -1, 1, and +4. And then the y-intercept is -4. Okay, so this is going to be the one that's correct. Okay. All right, now, okay. Well, if you have a polynomial with real coefficients, then if you have a non-trivial complex number, then its complex conjugate is also a 0. Now, f has degree 3, which means that there are exactly 3 zeros if we count any 0 that's repeated. Okay. And so it's known that 5 is one of them, and 4 minus I is another one. And so there's only one left over to find. Well, this is a complex number, and so its complex conjugate will be the remaining 0. And how do you find the complex conjugate? You change the sign of the I term. So that's all you change. Okay, so that is the missing 0. I'm going to type in 4 plus I. Okay. What is or are the zeros of this polynomial function? Well, this is where you really need to graph it. Right, so let's see what we have. Okay, so I'm going to put x cubed minus 7x squared minus 7x plus 49. And I'm going to start with a zoom 6. Now, x-intercepts give you real zeros. Okay, I've got 3 distinct x-intercepts. So there will be 3 zeros, and there'll be 3 real zeros. So this one's not correct because it has I. This one's correct. It's incorrect to say that there are no zeros. And then it says you just get 7, but it's repeated 3 times. That's not the case here. And we can see right here that positive 7 is a 0. Okay, this last one is wrong because it has complex numbers in it. We have 3 x-intercepts, so we will have 3 real zeros. And you can see here that 7 is one of them. So what I'm going to do, so from the graph we can see that 7 is a 0 because 7 is an x-intercept. So I'm going to use synthetic division with 7. Okay, and I'll have 1 minus 7 minus 7 and 49. 1 times 7 is 7, then we add. 0 times 7 is 0, and then we add. And negative 7 times 7 is negative 49, and then we add. Okay, now, my remainder is 0. That means the number in the box is a 0. That means x minus the number in the box is a factor. So we can factor f of x now as the divisor, which is x minus the number in the box, times the quotient. That's my constant, that's my coefficient for x, that's my coefficient for x squared. So I'm going to have x squared plus 0x minus 7. So again, there's that result that we've been using all semester. If you have something like that, it always factors. X minus the square root of k times x plus the square root of k. And here the number is 7. So I'm going to have x minus 7 times x minus the square root of 7 times x plus the square root of 7. So what are the zeros? The zeros are 7. If x is square root of 7, that'll make the whole thing 0. And if x is the negative square root of 7. And so that first is correct. All right, what are the zeros of this polynomial function? Again, look at it in the graphing calculator. So let me get rid of this. So we're going to have 49x cubed minus 343 x squared minus x plus 7. And I'm going to start a zoom 6. Okay, so we can see that we have 7. And we have 2 other real zeros there that are between -1 and 1. So I definitely have 7 as one of my zeros. I'm going to change a window now. Because I want to see where those other 2 zeros are. Oh, yeah, okay, I'm going to graph. Okay, so here's -1 and 0. And here's 0 and +1. So I have an x-intercept. Now look at the selections. Okay, the square root of 7 is like a big number, like 2 point something. This is matching up 1/7 and -1/7, because 1/7, here's 0 and here's 1, and 1/7 would be there. You can always use synthetic division, okay? But I think from looking at the graph, it can only be that one. Okay, because what is the square root of 7? Second, square root of 7. Okay, it's 2.6 something. And on that graph, if I do a zoom 6, I don't have any x-intercepts at 2.6 and -2.6. So the only one it can be is that one. All right, what are the zeros of that polynomial? Okay. Well, there are zeros. It has degree 3, so there will be 3 zeros. Now look at all of the other selections. They have that 5 is a 0. So we don't even have to look at the graph. 5 will be a 0 because of the other selections. So I'm going to do synthetic division with 5 in the box. If it is a 0, you have to have a remainder of 0. So I'm going to do synthetic division. And when I add those, I get 0. So my remainder when I do synthetic division is 0. 5 is a 0. X minus 5 is a factor. So I can write f of x now as x minus 5 times the quotient. And the quotient, that's my constant, that's my coefficient for x. That's my coefficient for x squared. So I'm going to have x squared plus 25, and then plus the remainder, which is 0. Now, if you have x squared plus a number, that will factor, but not over the real numbers. It's going to be x minus the square root of k times I times x plus the square root of k times I. So for this one, I'm going to have x minus the square root of 25 times I times x plus the square root of 25 times I. So what are my zeros? What will make these 0? Well, if x is 5, if x is 5i, that will make that 0, make the whole thing 0, and if x is negative 5i. Now, if you look at the graph, you'll only see an x-intercept at 5 because these don't show up as x-intercepts. So I'll have 5, 5i, and negative 5i. All right, write the standard form of the equation of the circle with radius r and center h comma k. Okay, so we have to know the standard formula. So it's going to be x minus h all squared plus x minus k all squared equals r squared. Okay, so hk is equal to 0, 6, and r is equal to 1. Okay, so this will be x minus 0 squared plus x minus 6 squared is equal to 1 squared. And x minus 0 squared is, x minus 0 is just x. Oh, sorry, this will be a y here, my bad. And 1 squared is just 1. Okay, so this is the one that I'm looking for. Okay. So x squared, and that one there. All right, now we want to find the center and the radius of the circle with that equation. So we're going to have to complete the square. Okay, so we have x squared plus 8x plus 16 plus y squared minus 2y plus 1 equals 36. Okay, what I would do first is get rid of the 16 and the 1. Okay, so get rid of the 16 and then get rid of 1. It's just easier for me to do it that way by hand. Okay, so then I'm going to have x squared plus 8x. Then I'm going to leave a gap plus y squared minus 2y equals 19. Okay, now I need to complete the square. If I'm going to complete the square, then what I do is I'm going to add this divided by 2 squared. And so that's going to be 8 divided by 2 all squared is 16. Okay. All right, these already had it done for me. Okay, it was already done for me. Gosh. Okay, 17 is, yeah, all right. Let me start this one over. I don't think you're going to get one like this on the final. So they've already got, okay, that's already been done for you. Okay. All right. Okay, well, this is 6 squared. Now this, we can use the trick to factor this. Two numbers that multiply together to give you 16, but at the same time add up together to give you positive 8. And that's 4 and 4. And then I have two numbers here that multiply together to give you positive 1, but add up together to give you negative 2. And that'd be negative 1 and negative 1. Okay. So this is the same thing as x plus 4 squared. And this is the same thing as y minus 1 squared. Now, it's not quite in the way that we need it. So I didn't have to complete the square in this one. It was already done for me. Okay, so the only thing is, remember in standard form, it's x minus h. Okay, so if the center is h comma k, it's written as x minus h squared plus y minus k squared is r squared. Okay, so I can see that my radius is 6. Okay, I have to rewrite this one. It has to be a minus here, so this is x minus negative 4. Okay, so my radius is 6. And x minus h, so h is negative 4, and y minus k. So my center is going to be negative 4 comma positive 1, and my radius is going to be 6. Okay. Negative 4, positive 1, and radius 6. Okay. Now, with this one, we'll have to complete the square. Okay. Okay, so let me get this down. I have 4x squared plus 4y squared minus 12x plus 16y minus 5 equals 0. Okay, so I'm going to get the 5 to the other side. Okay. And I'm going to put my x terms together. And I'm going to put my y terms together. That's what I have so far. Now I can factor out a 4 here. And if I divide this by 4, I get minus 3. I'm going to leave a gap. And I can also factor out a 4 here. I'll leave a gap. Okay. Now, what I do to complete the square is I take this one, negative 3, divide it by 2, and then square it. Okay. So when I square that, I'm going to get 9/4. I have to do the same thing to the other side because I've changed this, but I don't add 9/4. I'm actually going to have to add 4 times 9/4. Okay, so I'm going to have to add a 9 to both sides. And then for this one, I do the same thing. I take this number, 4, I divide it by 2, and I square it. So 4 divided by 2 is 2, and 2 squared is 4. So I'm going to add 4 inside here. But what I've really done is I've multiplied, I'm going to have to add 4 times what's on the outside. So I'm going to have to add 16 to make sure everything's the same here. Okay. Now, when I do that, we can have, I'm going to have 4 here, times, this will be x, and then plus this number over 2, all squared. And because I've completed the square here, this will factor as y, and then plus this number divided by 2, all squared. Okay. And here I'm going to have 5 plus 9 is going to give me 14, and 14 plus 16 is going to give me 30. Okay, I'm nearly there. All right, I can't have these 4s out the front, so I have to divide everything by 4. So I'm going to have x minus 3/2 squared plus y minus -2 all squared is equal to 30 over 4. That's going to be the square root of 30 over the square root of 4 all squared. And the square root of 4 is 2. Okay, so when I do it like that, my h, it's x minus h, y minus k, and r squared. So my center should be positive 3/2, comma, -2, and my radius is square root of 30 over 2. Okay, so I'm looking for the center of positive 3/2, comma, -2. All right, that makes it the middle one. And then I want square root of 30 over 2. Okay, and that's all we can do with that one. Okay, so square root of 30 will not simplify. Okay. All right, find the standard form. Okay, so let me get my pen here. All right, let me do this in red. Okay, I'm thinking that the center, now they want standard form. So these two are not standard form. Standard form is the first or the last, okay? And what do we got here? Let's look at the scale. 2, 4, 6, 8. The scale is 2. Here. So it looks like I have the center about there. Okay, well, why isn't that marking? Oh, looks like my center is about there. Okay, so if the scale is 2, this looks like the center is at -1, comma 2. So it looks like my center is the point -1, comma 2. And it looks like my radius is, well, the distance from the center to any point. I take that horizontal distance. Okay, it looks like, so that's where 1 would be. And then this first grid is 2. So my radius is 3. Okay, so I'm going to have x minus h, and h is -1. So x minus -1, x plus 1 all squared, plus y minus k, k is 2, all squared, is equal to the radius squared, which will be 9. Okay, so that's matching up this one here. Okay, so okay, there's always one like this on the final, so we absolutely have to know how to do something like this. Okay. And these were of the same caliber that I chose on web work, so but a lot of you missed it, so you have to work out what's going on here. Okay, so let me get this guy out of the way. All right, so we have, okay, so it says Bob Gromsky wants to build a rectangular building and the perimeter will be 500 feet. So the perimeter means when you add up these four sides, you'll get 500. Now we're told that the length is 20 feet fewer than the width. So the length is going to be equal to the width minus 20. That's what that sentence says. The length will be 20 feet fewer than the width. So I'm going to let L be length and W be width. So we've got length and width. And now with this, my model is W minus 20, W minus 20, and W. Okay. So the perimeter is when you add up all four sides. So I'm going to have W minus 20 plus W minus 20 plus W. And if I combine all my W's, I have 4W, 4 times W. And then minus 20 is minus 40. That's my perimeter. But we were also told in the problem that the perimeter is 500 feet. Okay. All right. So now we've been asked how wide will it be? What's the width? So we just have to find W. Okay, add 40 to both sides. And then divide both sides by 4. Okay, I get 135. So the width is 135. All right. Okay, now we have set theory. Okay. So we have a universal set, and they just want to know what's the intersection with A and B. Okay, A intersects B. Okay. All right, so here's what we're going to do. Let's see if I can. Okay, so I want A intersect B. So I'm going to write A intersected with B. The intersection is the set that's formed from elements that are in both. Okay, so 1 is not in both. So 1 is not in the intersection. 2 is in both. So it is in the intersection. 3 is in both. So it's also in the intersection. 5 is in both. So it's in the intersection. And then 8 is not in both. And then we're done. We just have to go through one set entirely. So that is my intersection, 2, 3, and 5. Okay. Okay. All right, now we want C union D. Okay. All right, so I'm going to write C. What we want C union D. So I'm going to write C underneath it, V, W, X, Y, Z. And we want to take the union with D, and D is just containing S. So union is you form one set with everything, but you don't write repetitions. Now, S is the only thing in D, and we can see it's not in here, so that's good. We're not going to have any repetitions anyway. Okay. Now, they might write it in a different order. If they write it in alphabetical order, then the S would come first. So the order doesn't matter, but you just can't have repetitions. So S, then V, W, X, Y, Z. That would be the union. Okay. Now they want, we're going to use this universal set. Okay. So my universal set, let me write this down. Write it down here. Let me get my camera up. My universal set is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now we want the complement of B intersected with the complement of C. Okay. All right. So B is equal to 2, 3, 5, 7. So I need to get the complement of B first. Now the complement of B is everything in the universe that's not in B. So 0 is not in B, so it's in its complement. 1 is not in B, so it's in its complement. 2 is in B. 3 is in B. 4 is not in B, so it's in its complement. 5 is in B. 6 is not in B, so it's in its complement. 7 is in B. 8 is not in B, so it's in its complement. 9 is not in B, so it's in its complement. Okay, now let's write down C. And now let's get C complement. The complement of C is everything in the universal set that is not in C. So 0 is not in C, so it's in the complement. 1 is in C. 2 is going to be in the complement. 3 is going to be in the complement. 4 is already in C. 5 will be in the complement. 6 will be in the complement. 7 will be in the complement. And 8 will be in the complement. Okay, now what have we been asked for? We've been asked for this. So now put them next to each other. Now intersection means they have to be in both sets. We only want elements that are in both sets. So I can see 0 is in both, so it will be in the intersection. 1 is not in both of them, so it's not in the intersection. 4 is not in both of them, so it's not in the intersection. 6 is in both, so it's in the intersection. 8 is in both, and so it's in the intersection. 9 is not in both. So I'm looking for 0, 6, 8. Okay, and the last one is we have a right triangle. Okay, so let me draw this. Now remember, with the right triangle, you have 2 legs and a hypotenuse. The hypotenuse is the side opposite the right angle, and it's always the longest side. So I've written on all of my paper. I'm trying to use the back, but I've got stuff written on the backs too. So that's some decent paper. Okay, here. All right. So let me move this up. Oh, no, I can't. Okay. Okay, the first leg has length. Okay, so we have a right triangle. The hypotenuse is always the side opposite the right angle. Okay, and then these are 2 legs, and you can just call first leg and second leg. So leg 1 and leg 2. Okay. All right, now the first leg, and it didn't matter which one I called leg 1, it has length 35. Okay. And that's 2 less than the length of the hypotenuse. So the hypotenuse has length 37. And what is the length of the second leg, or the remaining leg? And here's where we use Pythagorean. Pythagorean says that the hypotenuse squared is equal to the sum of the other 2 legs squared. So I'll have this leg squared plus this remaining leg squared. Okay, so I'm going to get this over to the other side by subtracting. So I'm going to have 37 squared minus 35 squared, and that will give me my remaining leg squared. So leg 2 squared. Okay, so if I do 37 squared minus 35 squared, then I get 144. That's my second leg squared. So I need to take square roots of both sides, and the square root of 144 is going to be 12. So I get that the second leg is either plus or minus 12. You can't have negative length, and so this has to be positive 12. So my remaining leg is going to be 12. Okay, and that finishes the test. Okay, and so I just submitted that, and I didn't get anything wrong, so that's good because I hate to go back if I miss something. All right, so that completes this video.